Hello. All right, guys. Hello. So what we're going to do is do some synthetic division practice. In class, we looked at how long division and synthetic division are connected, and you could use either skill, but synthetic division you can use for a smaller set of examples, okay? And in order to get the hang of it, I'm going to go ahead and work out a few more examples for you. And lastly, we're going to see some of the cool things that you can do with synthetic division. Let's do it. Okay, synthetic division practice. And right, we're just going to do some examples here. Okay. Let's do x cubed minus 5x minus 36. Okay, notice that this is not a quadratic, it's cubic. Okay, divided by x plus 4. So the first thing we're going to do to set this up, and I like to keep a pencil handy here, is I'm going to make columns starting at the highest degree. Cubed, squared, x, number. Okay, those are my columns. And I'm going to use 2 rows. And I'm going to DDM, drop, drop, multiply. Drop the coefficients. Notice that I put a 0 for my missing x squared power. Okay, drop, drop, multiply. Okay, drop, drop, and those are the coefficients I'm talking about. Okay, drop the leading coefficient right there, and multiply by the 0. Okay, which comes from this part right here. Most of us can do this pretty quick in our head. Okay, I am all set up. Now the pencil is just helping me keep my numbers organized, just like I do in long division. Okay, so I'm going to switch to red so you can see what I'm going to do. Times, add. So it's multiply, add. Negative 4 times negative 4 is positive 16. Add positive 11. Okay, this is minus 44. Add negative 80. Write your answer. Okay, so I'm looking at this. I had a cubic divided by a linear. That means that my degree is going to decrease by 1. So it's going to be x squared, x, number, remainder. Okay, you always go down degree by 1 each time. You have to make it to this remainder slot. If you missed something, this won't work. Okay, equals 1x squared minus 4x plus 11. All right, watch how I'm going to write my remainder. Plus negative 80 over the divisor. The remainder is negative 80. Okay, let's do another example. And then we'll start looking at some of the super awesome things we can do. All right. Here we go. 2x squared minus 5x minus 4. Okay. This time I'm going to write it like this. Divided by 2x plus 1. Oh, synthetic division says that you can't divide by this because it's got a 2 in front of the x. And so what I'm going to do is I'm going to rearrange or manipulate this 2x plus 1 into a slightly different appearance. I'm going to take this 2 and I'm going to factor it out. All right, notice you can check with distribution, and notice that if you distribute, you actually get this piece right here. And so we have 2 ways to do this, and I'm going to show you both because you might be more comfortable with one versus the other. Notice that we are dividing by both 2 and x plus 1/2. Okay? It actually doesn't matter which one you divide by first. And so over here, I'm going to do the divide by 2 first, which means I'm just going to take all my coefficients and I'm going to divide by 2. It's not synthetic division because I'm not dividing by the factor. I'm just dividing by the coefficient. So first, I'm going to divide by 2. And that leaves me with x squared. Eek. That's all right. You can do fractions. Don't worry. And next, I'm going to do the divide by, and that's where the synthetic division comes in. You can only use synthetic division when you have a linear factor with a 1 in front of the x. So let's set up our synthetic division. DDM. Drop, drop, multiply. 1. Okay, drop, drop, multiply. Minus 1/2. Okay, I like the columns because it helps me keep my numbers ordered and I don't lose these subtractions. So this is minus 6/2. This is positive 3/2, which is minus 1/2. Okay, let's check. Did we miss any columns? We started with quadratic and I divided by linear, so the degree is going to go down by 1. So we're going to start at x, number, remainder. Okay, let's write it out. Equals 1x minus 3. Okay, remainder. Keep in mind that what did you divide by right now? You divided by x plus 1/2. Okay, now I'm going to put a plus here and I'm going to write my remainder. And as I do that, I'm going to pull a little post-it note out because I'm a little bit out of space here and I'm going to show you something. Okay, so here's my remainder. And I'm going to put it over this piece here that I divided by. This is called a complex fraction. We don't want a complex fraction. And so how do you divide by a fraction? You multiply by its reciprocal. Okay, top divided by this is really times the reciprocal, 1 over that. Notice that really the 2 is in the denominator, okay? So is the factor because in the denominator means you're dividing by it, all right? And so what I need you to remember is, I'm going to give myself just a wee bit more space. Okay. Okay, there's my remainder. I'm going to place this right here. And I don't really like how I have these two pieces here. Yes, okay. So I'm going to go ahead and write it like this. X minus 3 plus, I'm going to redistribute. And now it looks like I divided by 2x plus 1. And I did. I just did it in 2 steps. Okay, so now the other choice is first you divide by. Okay, so let's do it. And it's up to you how many fractions you feel like dealing with here. 2 minus 5 minus 4 minus 1/2. Okay, DDM. Okay, now I divided. Okay, so it's a degree of 1. So this is x number remainder. Got my columns. Okay, and write it. Now, what I have is 2x minus 6 plus the remainder. Okay, note, I divided by x plus 1/2. Okay, the second step is going to be divide by 2. Now that's a coefficient. Notice that dividing by 2 is the same thing as multiplying by 1/2. And so let's do it. Equals divide by 2. Okay, divide by 2. Now because that's already a fraction, I'm actually going to do the times 1/2. What? Yes. Same exact result. Mind blown. Okay, let's keep on going. Pause it if you need to. Okay, here we go. 3x cubed minus x squared minus 3x plus 1 divided by 3x minus 1. Oh, okay, I can't do that because this is not a linear factor with a 1 in front. And so I have to change this into 2 steps, which means I'm going to factor the 3 out. And now I'm going to choose. I kind of like doing the coefficient second because as I look here, I realized that I would get a couple fractions, all right? And so I'm going to choose to divide first by the factor, and second, I'm going to divide by the 3, which is also, right? You can look at it either way, times 1/3 or divide by 3. So let's set it up. DDM, drop, drop, multiply. Columns, cube, x squared, x number. Writing out the columns also helps me make sure that I don't skip any degrees. Okay, right, I include my pluses or minuses. And DDM, drop the coefficients, drop the leading, and multiply. All right, 1, oh, that's pretty nice. 0, 0, minus, what? Okay, remainder 0. That's all right. So let's go ahead and write down what we have. So we have to decrease the power by 1. Now I'm going to include the 0 just so you see what's happening. What did we divide by? We divided by this. Okay, now you either have to divide by 3 or multiply by 1/3. Okay, so let's divide by 3. Here I'm going to choose to multiply by 1/3. Don't need to write the middle term. And plus 0 over, okay, I don't want to leave my denominator like this. Notice how it does match what I started with. Now that's 0 on the top, so that's actually just 0. So the answer is x squared minus 1. All right, so this is our final result. Notice that there was no remainder in this question. Okay, let's do, ooh, this is a good one. I like this one. Question 4. X to the 5th minus 32 divided by x minus 2. Okay, drop, drop, multiply. Drop the coefficients. Okay, fifth, fourth, third, squared, x. Whew. Okay, it's getting a little bit long there, but I think we can do it. Drop, drop. Okay, multiply. Ready, go. Look at those numbers. Ooh, that's a remainder of 0. Okay, what is our result? X to the 5th minus 32 divided by x minus 2, right, equals, decrease by 1. Equals 1x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. Now, I'm going to do something here that's going to lead us into one of our really fancy results. I'm going to take this piece right here, this piece that I'm dividing by, and I'm going to multiply it to the other side. What? Yeah. So I'm going to put parentheses right here. And I'm going to take this yellow portion and I'm going to multiply it, kind of like a cross multiply. Right? This thing's over 1. I'm just going to cross multiply this over. X to the 5th minus 32 equals. I'm actually going to put it in front. Wow, it kind of looks factored. It does look factored. And that leads us to our first big discovery. Notice that my remainder was 0. Okay? And that tells me that when I do this little cross multiply thingy from my answer, that I end up with a factor. Okay? I end up with a factor. If the remainder is 0, then this becomes a factor, and it helps you rewrite your polynomial. Remember all those factoring techniques and those bubbles? We've now added synthetic division to one of those bubbles. Okay, so let's do a little more investigating here with this factoring piece. All right, so we're going to pick something that is a little bit, okay, x to the 4th minus 9x squared plus 20. Okay, divided by x minus 2. Let's see what happens. Now, I'm going to do this little sneaky work here. Off to the side. I see quadratic form. Okay, which is x squared minus 4. Okay, dokie. All right, which is actually x minus 2, x plus 2. Oops, squeeze it in. Okay, so I can see that x minus 2 is supposed to be a factor. But I'm going to do synthetic division because that's how this problem is set up. Okay? And I want to see how the work connects. Remember, this year is not only about learning how to do different skills, but learning how these different things are connected. Okay, DDM, drop, drop, multiply. 1, 0, minus 9, 0, 20. Drop, drop, multiply. Okay, set it up. Now I'm going to switch colors. 2, 4. Remainder 0. Yes. Okay, what did we get? Now I started with the 4th and I get a 1. So this is cubed squared. X number, yes, remainder all the way to 0. Fantastic. All right, so let's see what happens. Equals x cubed plus 2x squared minus 5x minus 10. Yeah, all right. So as I'm looking at this question, I see grouping. What? So I did the division, okay? And I'm going to put it around a little box here. This is the division answer, right there. But I'm going to ask you a question. Can you use x minus 2 as a factor to completely factor the expression? Okay, so I told you that x minus 2 is a factor. Can you use it to completely factor this expression? Notice how there's not a division in this problem, okay? But because you know that x minus 2 is supposed to be a factor, we are going to do the synthetic division to break this down from a quartic to a cubic. Drop. Drop. Multiply. All right, I know the work is the same, so I'm just going to do it quick. Okay, but watch what I'm going to do. Instead of, okay, notice this is what I'm doing. This is factoring, factor with synthetic division. Okay? It's right, I'm using the skill. I didn't actually ask you to divide, but you're doing the division in order to factor because the remainder is 0. This is what factoring with synthetic division looks like. It's not grouping where I split it up. It's not U sub. It's not a GCF. It's synthetic division factoring. So as I write my result, I do this. Bop, bop. Okay, that's going to write our polynomial. X minus 2, and the result is, I get so excited when, okay, remainder 0. 1x cubed plus 2x squared minus 5x minus 10. All right, what's equal? This is what I started with. I used synthetic division, and this is my second line of factoring. That's it. And then you can mix and match methods. Match, TCH. You can mix and match. I see grouping, so I'm going to do grouping. I feel like it's too colorful. Okay, finish the factors. Green box, completely factored. Wow, synthetic division can be used to completely factor. That is fantastic. All right, now we're going to try another one. Given that x plus 5 is a factor, okay, completely factor x to the fourth, oh, no, x cubed, my bad, x cubed plus 4x squared minus 11x minus 30. Whew. Now, just for grins here, I'm going through my bubble list. Cubes, no. Squares, no. GCF, no. Grouping, no. Nothing's working. Let's see, what else did I have? Quad form. No, it's not a trinomial. It's obviously not a normal. Okay, guess what? There's no more bubbles to choose from. Our next bubble is synthetic. All right, they told me which one of the factors is, so we're going to use that to see if we can't break our cubic down into a quadratic and then hope to use one of my other bubbles. All right, so I'm going to highlight my bubble. Number 1, that's what I'm doing first. D M. Set up. Multiply. I've been known to make silly arithmetic mistakes, so just check yourself. They're telling me that this is a factor. You're expecting the remainder of 0. Okay, how do I write a polynomial? So, there you go. That's it. X plus 5 decrease by 1. Right? I did this divided by that. And then I come back up here and I look at my bubbles. I'm like, okay, what else can I do? I can do normal quadratic factoring. Wow. Fantastic. Just for grins, I'm going to give you this one. Factor using synthetic division. What? But I know the formula. Doesn't matter. I want you to do it with synthetic division. One factor. You have to pick out one factor. Right? You have to know that. X minus 2 is a factor. X equals positive 2 is a 0. If you plug in 2, you get 0. DDM. space it out. You don't want to accidentally mush these numbers together. And multiply. My goodness, no way, you're kidding me. Yeah, so fancy. So fancy. Okay. Rewrite into the factors decrease by 1. Now I'm boxing it because we already know that second piece is prime. What? Okay, so I'm going to just start highlighting this here because that's bringing us into another piece of our discovery here. All right, the skill is now simple, but how do you use that skill is what we're developing. Okay. X minus 2 was one factor, but x equals 2 is a 0. And so over here, I'm going to do this. See that? If you plug in 2, you get 0. What is the remainder? 0. So I've highlighted all of these things that are connected. Okay. Factors are connected to zeros. Factors are connected to zeros. Wish you could see my face. I have a giant grin on. Zeros are connected to remainders. Okay, now I want to connect it even further back. All right, notice that this is 5, 5, 5, 4. Zeros is 5, 3. Factors is 5, 2. Remainders is 5, 4, and 5, 5, right? Long division, synthetic division. I want to connect it back to 5.1. X-intercepts. Polynomials is one of my favorite units because it's all so mixed in terms of using your skills and understanding all of the connections. This is where you really start your Algebra 2 knowledge. Before this was not quite there with our conceptual understandings and applications of our skills. Okay, let's do another one. And as we do the next one, I'm going to start bringing in a little more of this 5, 2, 5, 1 piece. Okay. Let's see. Ooh, cubed. What? Factor. Okay, so if I'm supposed to factor this, I'm going to make up that 2x minus 3, right? That's a factor. I know that a 0 is 3 over 2. Now I know the formula, but I'm going to do it with synthetic division to just show you how this works. Okay, so the first thing I'm going to do, eek. All right, guys, see this? If I'm going to do synthetic division, I got to rearrange my factor here. And so I am going to divide by this first, okay, d squared 1 d d n. Notice that the 0 does match that factor. Okay, so we get 24 over 2, so that's a 12. 36 over 2. 18, yeah, 18. Okay, 27. All right, whew. So let's write it down. 8x squared plus 12x plus 18. Next, right, I am going to divide by the 2. Okay, but I do need to actually write my result. Right, okay, so this, right, that's what I divided by. And answer. Okay. Wow. Square, opposite product, square. Yes. Okay. X intercept is 3 over 2, 0. Okay, we are making the connections. 5, 2, 5, 3, 5, 1. The whole work is 5, 4, and 5, 5. When I look at this graphically, 1, 2, I'm going to see a cubic function that is bottom left, top right. Check that out. Bottom left, top right. I'm going to have a negative 27 y-intercept and this. This is not a POI. Notice the multiplicity is 1. 1x-intercept. If I were actually solving this, I would get imaginary answers. 1 real, 2 imaginary. That's why you don't see any x-intercepts.